G'day students. So let's have a look at doing an IB question. We're going to do one question a day in the lead up to our exams, looking at past paper questions, and we'll sort of step out how we do each ones. I'll focus on the multiple choice to start off with in the series, and then we'll expand into the larger questions as we go. But we'll still go through step by step how to work it out from beginning to end. We'll try and leave sort of nothing for granted. We'll give you as much detail as we can on how to answer those questions, how they work. So first up, we have a balancing equation question. I'm going to get you to pause the video, read the question, and then we'll go through it together. So the question is asking us, what's the sum of the coefficients, that's the numbers out the front, of the balanced equation for the combustion of iron sulfide, that's this one right here, with oxygen, because they always are. It doesn't say with oxygen, but combustion means with oxygen. And it gives us our products here, and we need to balance this equation. I really like the way the IB does balancing equations for multiple choice questions, as I've not seen another system that does it quite the same way, but it works really, really well from an examiner's standpoint. You've got these lines here. That shows you where the coefficients are going to go. That can be a 1, which means you normally wouldn't write it there. So remember that. But okay, so let's have a look. So the first thing we would do, because we want to do complete working, and we show how to do this. And for our balancing equations, that always starts us with an ERP table. So what's an ERP table? An ERP table, for those of you who aren't in my class and see this all the time, stands for elements, reactants, products. Okay? Nice and straightforward. Elements, reactants, products. Now, what we do is the first thing is we write down the elements as they appear. Well, actually, we write them in the order of metals, non-metals, then oxygen and hydrogen, which we'll see why in a second. So we have Fe, S, O. We put a line underneath each of them just to keep it clear. You don't need to do that when you're doing it on your own paper. It's just to keep it clear on the screen. Then we write down how many of each element we have on each side. So on the reactant side, we have 1 iron, 1 sulfur, 2 oxygens. In the product side, we have 2 irons, 1 sulfur, and 5 oxygens. So we write that down. Now, as I said, there's an order that we balance, and we balance in metals, non-metals, oxygen, hydrogen. I know that hydrogen and oxygen are non-metals, but we separate them out just to make it easier. That's just the good order to do it in. So in that case, we want to balance our iron first, right? We have 2 iron on the product side, 1 iron on the reactant side, so we just multiply it by 2, right? And then we update our table to reflect that. So we have now 2 irons, but we also have 2 sulfurs. So you'll see our sulfurs were actually already balanced, but now they're unbalanced, but our irons are sorted. So that means our next one we want to deal with is our sulfur, because that's our non-metal, that's not oxygen or hydrogen. So we have 2 sulfurs over here, 1 over here, so we probably want to put a 2 out the front of that. So we do that, and that updates, and that changes our oxygens. Okay, this is why we leave oxygen till last. So we now have 2 sulfurs on this side, 2 sulfurs on this side, still have 2 irons on this side, 2 irons on this side, like that all stayed balanced, but we now have 7 oxygens. And that's the last one we need to balance. So, what's the common number between 2 and 7? They can both multiply, or they can both sort of factors of 14. Not a maths teacher. So, because they're both factors of 14, that means we kind of want to get the oxygens to 14s on both sides, because we don't want to do any fractions. Alright, so how are we going to do that? On this side, it's pretty straightforward. We'll put a 7 out the front of that. That's going to make 14. But here we need to make a choice. We can multiply the sulfurs, or we can multiply the oxygens, but it's not straightforward. I'll show you why. So if we multiply this one by 2, that gets us to 6. And then we put 8 there, so multiply that. That's going to get us our 14. We couldn't just do that, because as we change this, we're going to have to change this again, and so on and so on. So this gets us 14 oxygens on this side, 14 oxygens on this side. Now, you'll notice we've unbalanced our ions and sulfurs, but luckily they're stuck together over here. So we just do a quick little bit of maths on the left-hand side there by changing the coefficient over here to 4. Right, now we have 4 ions, 4 sulfurs, 14 oxygens. Check out your maths. 4 ions, so 4 times 2. 4 sulfurs. And then we have 2 times 6, so 6, plus 2 times 4, that's going to be 8, 14 oxygens. Now if we add those together, it gives us 17, which means the answer is D, 17. All right, that's our first question of the day. If you subscribe, you'll make sure they keep popping up in your feed and all that sort of nonsense. And we'll see you tomorrow for the next one. Bye now.